Guys, as I've said, as we've gone through and I put on the calendar and everything like that, we're looking to quiz in midweek here. Whether, my guess is probably, I'm leaning more towards Wednesday. I think on the calendar I have it set for Tuesday, but I think Wednesday's probably a little bit more realistic on that one. Hey, Mr. Pitts, could you do me a favor? Would you unplug your earphones, please? Thank you, sir. Appreciate it. So, what I want to make sure that we got down pat here is the fact that you can use your sheets and put a string of thought together that makes sense. That's what they're there for, okay? That's what they're trying to hopefully get you guys to do. Now, in the example that I have here, we have midpoint of AE, and I have a midpoint of DB. Excuse me. So, we need to write out some stuff. When you start with these proof things, obviously the first thing that you're always going to do is write down your givens and then draw your diagrams, okay? As you are given things about the proof, especially things that have definitions, in this case, midpoint. What do midpoints do, guys? What's that? What do they do to the segments, though? They cut it in half. It means you point out with segment, according to your sheet, though, it says segment equal segment, or segment congruent segment, one of those two. Now, what I want to do is, well, do we have all this written up here? I'm just going to shrink it down a little so it fits a little better. We okay?
Yeah. Do.
Apparently I did not have that grouped. All right. All right. So let me move this just a little bit so I have a little bit more space.
So we have a midpoint. When you are given midpoint, if C is the midpoint of AE, that's our given. What do you write down then? What does your sheet say to do? Well, first we find it on our segments. We're looking at it. According to your progression sheet, it tells you to do what? Segment equals segment. Bless you. Now, segment equals segment, or segment congruent segment. Does it matter which one I'm going to use? Let's see. I'm trying to think here if we need... We're trying to show that AC... Eventually we're trying to show that this portion here is going to be the same as this portion here. So should we write it as equal or congruent, given the other stuff that we have? Let's start with congruent and see what happens, because everything else is incongruent. If we have to switch it to do an addition or something like that, we can do that later, all right? I would just say, hey, since the other stuff's already given incongruent, just go with that. So segment congruent to segment. So that means that AC congruent to CE. Definition of the midpoint. Is there anything else I can do with that first given statement? Nope. I do the same thing. C is the midpoint of DB. Another given. According to my progression sheet, tells me to do something else. Make sure that I have congruent segments. Well, that means these two have to be the same. Definition. Midpoint. And then it says that AE is congruent to DB. So those two big segments are already equal to each other. Okay? So if I do this, watch what happens now. Now, since these two whole segments have to be the same, Should that DC and CB have single or double tick marks? Should have single, okay? Should have single. So what I'm gonna do is just kinda, oops. Make that a single tick here. Same thing here. Now I have to figure out a way to save this stuff now. So the easiest thing to do is we know that we have two larger segments, and both those larger segments are made up of smaller segments. Do you agree? Now, if we're going to use two small equal larger, that's segment addition, correct? Is segment addition within equality or congruency? Equality. So what should I do, since right now I'm sitting at the two large ones, and I need to make them to an equal, what am I gonna do? Yeah, I'm gonna flip it to a congruent. Because what we're gonna have to do here is take these two being the large ones, and then just rewrite them as the smaller ones, okay? By using angle addition. So we know that AE was made up of what two segments? AC and CE. So I can write AE I know that. And DB was made up of DC and CB. And these are both angle addition. Are we okay with that? Now, the next one is that straightforward substitution. Okay? Because I have two things that are equal to each other that are equal to other chunks. See how we went from big chunks to smaller pieces? You use this step quite often. So then I know that I can take those two smaller chunks then and rewrite them equal to each other because of substitution. Oops. Okay. Now you're almost there. It's one of the longer ones because of the two different givens here. We need to show that, which was it? It was AC is congruent to CD. I had written as DC, but that's okay. I'm not going to worry about flipping that. Now, excuse me. Back up a while ago. We knew that, where was it? Since these two guys are equal to each other, and these two guys are all equal to each other, I can flip and put one in for each other now. So all we have to worry about, since everything's gonna wind up it technically could wind up canceling everything out. What do we have to show? AE or AC, and we gotta get these two set up. Can't I just say that this one and this one are the same?
Yeah.
So all we do is a substitution. Do you want to substitute CB for CE or CE for CD? Doesn't matter. What's happening here, guys, is that you had to do two substitutions. More often than not, with a lot of these proofs that we do, it's a lot of quick substitutions and subtraction. Because that's really all that we know how to do. You only know how about angle addition and segment addition. That's really it. There's nothing else that you can do. So you're going to wind up doing a lot of substitution. Just put something in for something else. And then how do we get rid of the CEs on both sides? Subtract property equal. And then lastly, just write it as a congruent. That's a really long proof for what we've been doing. Okay. Now, I know that it said that it had to be CD. Well, I will make sure that these first few proofs, like quiz-wise, you're not gonna be tricked with this last little step. How do you rewrite something that goes forward and backwards? Not reflexive. Reflexive, remember, is you are yourself. The other one, when you flip them back and forth, was what? Symmetry, yeah. I'm not gonna do that to you. Okay. But yeah, this is the kind of the idea where you start rolling through statements and trying to figure out where you're heading. I know sometimes it gets to be kind of messy, and that's okay. It's okay. Because other ones are really, really easy. Let's see one I'm just gonna skip this one. Let's do this one. Let's take we'll go to an angle edition one. We'll go back to a segment in a second. So you have perpendicular, you got some angles that are equal to each other. Oh, I'm sorry. Yeah. I mean to hit you in the head there. Oh, for those guys who are just coming back in, I collected I collected that proof stuff from last week that we did. So if you get a chance, you want to pull that out, I'll grab it for you in a minute. So we've got perpendicular. We have two angles that are equal to each other, and we want to show that the two, 1 and 3, wind up equaling 90. So one of the things that I would do on this, well, first of all, I would go and look at my progression sheet and see what it says about being perpendicular. If you recall, I think we had, like 2 or 3 different things to say off of perpendicular, depending upon the type of problem it is. We have 3. So I think we had, our right angles, yeah. Okay. So, excuse me. We have AB, or AB plus, excuse me, that's a perpendicular sign. AB is perpendicular to BC. Okay? Angles 2 and 3 are equal, and 1 plus 3 has to equal 90. So, we start with the given. According to your progression sheet, the next thing was to say, state the right angles that were formed. Now, this is an example that you might only have one right angle being formed. It's not on both sides, where we've seen it both ways now. So we have to say which right angle has been formed. Well, which one is it? ABC. That means that angle ABC is a right angle. Definition, perpendicular. You okay with that? Now, in the stuff that we've talked about with right angles, I think we had it 2 different ways. We would say that all right angles are congruent, or I think we left a little footnote in one of them saying that sometimes right angle just equals 90. I think we did that, didn't we? It should be on our sheet, right? So do we have to say that all right angles are congruent, or should we say that right angle equals 90 for this case? Right angle equals 90. So now I'm going to say that angle ABC is 90. What do you think the reason is? What's that? Yeah. I can just say, since we're using the definition of a right angle, just definition of a right angle. Okay. Now we have to get into where it's trying to lead you. Notice, you have 2 angles that make up the 90-degree angle. Then you have two angles that you want to, that are equal to each other, that you can kind of substitute in for, and then back one out. So in this case, what would I write next? What do you think? Pi. That's great. What two angles equal 90? 1 and 2. Why? Well, let's do this first. Angle ABC is angle 1 plus angle 2. What's the reason? Angle addition. Very good. Which means angle 1 plus angle 2 have to equal pi. Goodbye. Oh! He's not here. Oh, thank you. So I can substitute the 90 in here. Yep. Now I basically have used up everything that I can now out of that first given by going through that the right angles were formed, that the equal 90, we can do a substitution step. The second part here says what? What's the next given? Angle 2 equals angle 3. What do you think the next step is? Substitution. Very good. Now I have 90 equals angle 1 plus angle 3. Again, substitution. What the way that we started to write this out, are we supposed to prove it with the 90 on the right or on the left? So how do I flip it?
Change the order. What is that?
That reflects it. We just did this one. Symmetric, yeah. Symmetric. Okay. Now, you might have gone away from not having to do that step down here if by chance up here you wrote angle 1 plus angle 2 equals to the ABC and you could just gone down. Yes, sir?
Is 90 equals angle H? Is that what it is?
No, it's angle 1 plus angle 2.
That looks like an H. 90. That looks like a capital H. No, not there. Second to last. It looks like an H.
Okay, but I don't know why I would write an H considering I'm talking about angles 1 and angle 3. Context clues. Okay? Yay! All right, let's see what's the one here. I'm sorry, what? Oh. All right, guys. Go for it. You have the progressions. You have the progressions. You know exactly what to write. Trust the fact that you know how to do this. Okay? Follow your progression. And there, again, you're given this. You need to show this. What's the overlap that they have? So, do we all agree that you're going to have to add angles together at some point in time here? Yes. Are you in equality or are you in congruency to start? So what should you do? Change it. You can't add anything. There's no angle congruency, angle addition. It's angle addition, not angle congruency. For that, when you add two smaller to equal to large. Every time you do math, it's always with equals, not with what do you call it? Congruency. So you're given ABC
switch it. Okay. Now, before you can add anything, you have to define that something is there, just like we did in our proofs from last week. Whenever you had to add in that wedge in the middle or that middle segment, you have to define that it's there. The easiest way to do that is say that it equals itself. So what do you do about this? What is that? It's reflexive, very good. You are yourself. If you have to define something that's in between that's shared, you have to say that it's equal to itself. Then you can add it to both sides. Okay? Because now I can say that I can add that CBD to both sides of the equal sign, and it doesn't change anything, okay, by using not angle addition, but just addition property of equal. So now I can do this. ABC plus angle CBD equals and what we did here was add prop equal. We added the same thing to both sides of an equal sign. It was already, the two small chunks were already equal, and we added the middle wedge to both sides to keep it equal. Okay? We're just adding the same thing to both sides of an equal sign. Now, we've got two smaller segments on one side, two smaller segments on the other side. Can we define what those two smaller segments equal? When you add two small, did I say segments? I meant angles. We have two smaller angles adding, well, we can create a larger angle, correct? How do you do that? Angle addition. I can then say this, that angle ABC plus angle CBD equaled what? ABD? And the same thing here. These two angles equal, what was it, CBE. And both of these two were just angle addition. Okay. We knew that we had two smaller chunks, two smaller angles that add up to be a bigger angle. Because that's what it said. We had two angles. Those two angles can add to equal a larger angle. So now do I have, are these two things equal to each other? The two smaller chunk angles? Yeah. Do those two smaller chunk angles equal something different now? So what do I say about those two things? That they're yes? Pinching your face. Pinching their face. They're equal because of putting something in for something else? Substitution. Gee, look. Addition, subtraction, substitution. It's kind of the same thing every time. Substitution, and then last but not least, I think, definition. Very good. Okay. Most of our stuff that we're going to be looking at, over the course of the next couple of days is very, very generalized. There's not a lot of, there's really no trickery to anything. Yeah.
You didn't have any second one? What'd you have last year instead of original?
Wowie kazowie. Wowie
Yeah,
kazowie.
you can look on your, you can look on your history for it.
So I've got 4 of them here going up for you guys. 3 segments and an angle. Okay? Make sure you have progression sheets in front of you as you're doing these. Make sure you have your notes in front of you as you're doing these, because you may come to find out that a lot of these things kind of look the same. The letters may change from time to time, but for the most part, it's a very generalized scenario, okay? Give it your best, all right? You guys can do this.